So I introduce you, and then you can start with your talk. I'm very happy to introduce to you Oliver Grau. Oliver Grau is the Associate Director of Operations of the Intel Visual Computing Institute of the University of Saarland. Before he moved to Saarbrücken, he was working for BBC R&D, doing a lot of things that is related to his research interests, which are immersive virtual production systems, stereoscopic video production tools, and free viewport visualization. And I think some of these topics will be covered in his talk. Oliver did his PhD at the University of Hanover, so he's German, but lived in the UK when working for BBC for quite a while. So Oliver, it's yours now.
Yeah, thanks for the introduction, Oliver. So yes, this is really an attempt to cover what's going on in media at the moment. It's actually quite a lot going on. So by all means, this would not be a conclusive overview. I just should switch to the actual presentation. Okay. Can you see it now?
Yes.
Great. So by all means, this would not be a complete overview, but my aim is to touch a few issues on recent development of digital media. Of course, with an aim to point to my recent or my research interests, which are in immersive and interactive new experiences. So the kind of things I want to cover here is, after a quick introduction, I want to give an overview of media and user experience, starting with an historical view, what visual media does and is. And then just to scratch what I call the visual modalities, which are, you can see this as kind of parameters in how you produce visual media and present it, like high-res, high-frame, HDR, stereo, and others. And I also want to give you an overview of what is changing in from this classical setup, which is film, TV, and I also count now games into this, which is the new frontiers we see in visual media towards immersive and interactivity. I will go over a few more examples in what's currently going on from the hardware side. That's the displays and delivery. And then I also will give some examples of what I think needs to be done or needs to further expand it in terms of content creation and creation tools. So just to give a bit more background where I am and where I'm coming from, I work actually for Intel. And Intel is a worldwide organization in semiconductor equipment, but there's a recent shift. So in the good old days, Intel was just building, let's say, CPUs, and they came up with a white paper how to integrate these CPUs in a product. Nowadays, Intel is much more engaged with the application setups, down to actually even doing reference designs or complete designs of new products. And that includes also looking into the use cases. At the moment, my role is basically, as Oliver introduced earlier, as a director of the Intel Visual Computing Institute. And that is one of many institutes Intel is sponsoring. The research is actually carried out by university collaborators. In other words, Intel just funds projects. You see here a long list of topics, so it's going all over the computing space in terms of topics. And I'm based in Saarbrücken, and it's one of two centers actually on visual computing. Now it's the only one, because the one on the right, which was led by Stanford in the US, just wrapped up a month ago. And it's changing its form, basically. It's not longer full sponsored by Intel. So we are the one left. And the reason why Intel is doing this, it's to engage with more on a long-term timeline with what's coming up in research. And it's trying to connect to very effective research teams worldwide. So we are based in Saarbrücken. For those who don't know, Saarbrücken is in one of the smaller Länders in Germany. It's right on the French to France. Sounds like it's a very remote place, and actually it is, compared to my previous location in London. It's hard to get somewhere. You always have to consider traveling 5 hours plus. So I was invited to come to Linz, but that would have taken me 1 or 2 days to go forwards and backwards. So maybe another time. But Saarland University managed to get a huge critical mass in computer science. It's actually the biggest computer science campus in Germany and probably even in Europe. And that's why Intel was quite interested and excited about this location. From the overview, what the projects are, and that's my last slide on the IVCI. We are covering visual computing, and in my words, visual computing is about having a camera that's here on the right, real words, and connecting this with the virtual world, which is more from the computer graphics. And of course, you have in between also interaction, so that's multimodal scene analysis and interaction is the topic. And we have at the moment something like 15 active projects. Some of the, I think, light gray ones are already finished projects, but you can see there's a lot of things going on both sides of the fence, computer vision, computer graphics, and most of the projects are actually trying to link this up. So Oliver mentioned also, I worked a long time in broadcast industry for the BBC. So what is visual media now about? So I start here just with the classical 3. Cinema, of course, that's the oldest one around, but then also TV, starting in the 50s with broadcasting live images or filmed images. And I also count in video games, because video games are not longer a new medium, it's established medium. Also, these 3 have very different characteristics, although there is some form of convergence. At least in cinema and TV, we see at least production crews are now using the same cameras. That was not always the case. And I will give you an example later in the historical overview. Of course, what changed in the last years is the upcoming internet. And one way of seeing the internet is, yes, nothing much has changed in the way visual media is produced. The internet is just a carrier, so you can use YouTube to watch the latest TV shows or movies, and you can play online games. But there is of course a significant difference, and that's the feedback channel. So with the internet now, you are able to connect to either the producer or a completely new medium itself, if you like, social media, where you connect to friends and other groups, and you have much more possibilities to interact with the medium itself. So that brings us to what is media, visual media, and what are user experiences. At this stage, I would like to start with a historical overview, and I have actually a nice video I would like to show, which is actually setting the scene quite well. And I hope you can hear the sound now, which is not that important.
105 years ago, this photograph was taken with a very crude camera by the Englishman Fox Torton, father of photography.
Then, as now, a light-sensitive material captured the whole of the image over a short period of time.
and the image quality depended both on the sensitivity of the medium and on the optics. Even in the mid-19th century, the concept of film production and post-production was born. Some errors, like exposure and framing, could be corrected in the printing process.
Here's Fox told us that some print actually taking the picture. And this is how they have to develop the dry print.
The still photograph proceeded to the cinema. The freeze screen and the Riviera brothers made the first movie. That was 45 years ago. The idea of exposing a long strip of film by pulling it in controlled jerks under a lens led to the foundation of the movie camera and of the cinema. But it's persistence of vision in the human eye that determines the number of frames per second we need for acceptably smooth movement. Although film cameras improved and film got faster, quite early on the industry settled on the 24 or 25 frames we still use today. That's lovely. With the coming of wireless, pictures previously captured on film could be progressively scanned and sent across the world as fluctuating radio signals.
Something that makes even the modern wireless man go alive with wonderment.
Today, as film faces its losing battle with electronics, this is similar to what happens in the latest digital cameras. Under the lens, the image captured on a photosensitive computer chip is progressively scanned and digitally stored not on tape, but on new storage media, disk or solid state, and it can be stored in different formats and resolutions. Film and television have existed side by side for 60 years, but although films have always been shown on television, the reverse hasn't been true because until now the two systems have worked in different ways and at different resolutions. In the 1930s, television, John Logie Baird's completely new medium, produced ephemeral live pictures for viewing at a distance. Television needed new ways of producing and sending images, this time not by capturing the whole scene frame by frame, but by scanning with a flying spot of light and transmitting the resultant stream of analog data instantly to the viewer. Originally done mechanically at just 30-line resolution, scanning improved as electronic cameras and receivers were developed. By the 1950s, high definition meant 405 lines. In the 1960s, 625, and today over 1,000 lines in some parts of the world. Television's unique feature is that it can be live.
The camera is able to move quite freely around this place with you. What you're seeing is actually not here at all. This is virtual reality. Actually, I'm standing in a dull, plain studio.
This technically complex virtual studio sequence is shot in real time.
Yeah, that's a bit I don't want to go over further. Yeah, I hope that was not too confusing, and you might wonder why the hell starting with photography. Actually, some of the bits that were discussed here in this short video are still keeping us busy, even though all the film bit is gone. Film cameras still produce at the 25, 24 frames progressive if it's intended for cinema, like in like 80 or even longer years ago. And that's one of the things I wanted to summarize in my modalities. This is actually quite complicated. The how things are related to each other and what it means. So spatial resolution, we see a incredible increase recently, with cinema always setting the standard, but cinema is about 2K or 4K equivalent today's in the digital world. IMAX goes up to 10K on a much wider screen. Quite recently in television we saw a huge evolution. So around 2000 we were just having SD resolution, that's 800 pixels roughly horizontal. Today we have HD, that's 2000, and 4K is just in preparation. So we are seeing broadcaster actively upgrading their pipelines. And I come to this later. We also did already some tests with ultra high definition. On the PC, we see still something like HD resolution today as a standard, and 4K is coming. So what is also important is not just the pure spatial resolution. In order to get an image of a scene that looks natural, temporal sampling is also very important. That was mentioned in the clip before. So it started all with cinema, moving pictures. And cinema sets the standard 24 frames per second. This is actually far too low. If you know what the requirements are for displays, for example, it's at least something like 70 Hertz. Otherwise, you would see flicker. That was in times when we had CRT monitors. With a modern kit, we have something like 60 frames per second, but it's a different display type. With back illumination, the image is quite stable. It's not flickering. So why is 24 frames per second working? The reason is that in cinema you are in a dark environment, and because of this dark environment, your eyes or your visual system is switching to a night vision mode. And it's not that sensitive to flicker anymore. Recently, digital cinema was introduced, and that now allows also to go for other frame rates because of stereo. And actually, stereo here was one of the things where you could see 20 frames per second. Stereo is not enough because now you start again seeing flicker, because you have usually interlace, or simply it doesn't work that easy with stereo. You are more sensitive to flicker. So people like for The Hobbit tried 48 frames per second, and that caused a lot of debate. So people thought, hey, this film looks cheap, like cheaply produced, like video. Basically, because it has higher frame rate, it's the look and feel of the medium is more like a video. People thought, wow, this is a cheap production. That was, of course, not the case. It was done by Cameron, and he's just a pioneer. He did this milestone in stereo production before, the Avatar movie. So he was a bit frustrated about the flickering in the 24 stereo, and he tried out 48. The debate now is what I would think, just because we are used to see 24 frames per second. If we carry on and produce content for the cinema and see it with 48, the next generation would not moan about, because it's just you're used to it then. But if you see a high frame rate video, and that's on television, there were tests done on 120 frames per second or higher, you might be amazed how realistic suddenly the action looks like. So there is really something like a look and feel to cinema, and that's what this slide is about. There is a difference just made by the sampling rate of your medium. We see a similar move towards higher frame rates on the PC at the moment. I come to this problem later, because this actually has something to do with the technology, the display technology we are using at the moment. So what are the other modalities? I mentioned there are more. High dynamic range imaging is one. So people have had or have still quite high hopes about it as an innovator in media. It actually, if you have seen a good display and a good content, it's quite amazing. It looks like a slide, so nothing like the 208-bit basically dynamic range of a standard display. A higher dynamic range imaging display really adds a lot of realism to the scenes captured. Unfortunately, there are some downsides. At the moment, there is no consumer display available. Also, you have to keep in mind that if you place your setup in the living room, high dynamic range imaging needs slightly more controlled environments. So it's like in the good old days, in the 50s, when people put on the curtains so that the living room is darker because they had less contrast. Similar with high dynamic range imaging, you enjoy more of the range with more controlled or dimmed light around. The stereo had its heyday just a couple of years ago. I think now it's a bit in decline. It was enabled through the digital cinema, and actually we have seen stereo in the cinema every other 15 years or so, or 20 years. It comes and goes. There's still some issue with stereo. Yes, it adds to the realism in some cases, but then people found, hey, you can't just put any scene on the screen. There is a kind of grammar you have to follow. There is something like a depth budget, otherwise people get stressed. Yes, it's a medium rather than a means to get something with incredible realism on the screen. So this is still a debate whether stereo will last. At the moment we see Hollywood is dropping the interest a bit. But it is, oh, there's a copy and paste problem I see just. Stereo is just one modality that is always mentioned when it comes to immersion. I mentioned this earlier. Immersion is a bit of a combined package. So what makes a good immersion? It's something you can't make up just with a display setup or with the way of the content. It's a package of both. So I'm going often so far to claim you can also get immersed in a good book or even in a radio show. And it has something to do with imagination. I come to this later on. Interactivity, that is something new. There is probably also a good definition of what it does. And all the classical media, they don't provide you interactivity. So that's clearly an exciting innovation. The question is, how can we make this work in user experiences? Gaming is of course one of the answers. Yeah, media production is about telling a story, and I mentioned it. It's what is an immersive media? There is no clear definition. From our perspective, we can aim to tackle this problem from the technologically. That means making a system where you believe you are in the real world. That would help. That would be more a technical perspective. So that's the old virtual reality idea. You put somebody in a system and you emulate the real world, and he can't decide whether it's real or not. However, the big question from the media production is, how do we tell a story in this environment? And this is still something that is not clear. So I want to go over what is going on in displays, and then come back to the question, how can we produce content for these new emerging displays and visual experiences. So very recently there's a lot of interest in new displays, and some of the most famous ones, bottom left, Oculus Rift just made a huge stir in media industry and consumer industry in general. It's not new. The idea of head-mounted displays is an old one, but Oculus just got the timing quite right, because there are components now available from smartphones and others that have an improved quality of the display technology. And the computing also is going in favor of these new innovations. But there are also other form factors or devices like mobile. And I personally, I'm a big fan of tablets, because you can do a lot with tablets using them as devices in 3D, which gives you new interactivity and possibilities to interact with 3D content. On the bottom right, there are some things to increase the immersiveness by just putting more immersive setups near to you. So imagine at the moment we have 4K panels, but imagine you put 4x4 of these panels together in your living room, and you have an incredible amount of pixels available, and that is really making a lot of difference in these environments. So the old example is the cave from virtual reality. It's on the top. I think we can do, just with this upcoming display technology and imaging technology, we can do much better than the cave, which is probably also some 30 years old by now, or at least 20 years, can't remember. So that's very exciting. There's a lot of movements through this evolving new display technology. Yeah, stereoscopic I mentioned earlier. This is still not clear to me where it is going. The cinema is dropping a little bit the interest. I think what they haven't got right is finding the right form of narrative for stereo. So most productions had in the past, and still do, just in mind to amaze people. So some dinosaur tails coming out of the screen and everyone's shouting hey, but this works only for a limited amount of time, because after you have seen 1 or 2 dinosaur tails coming out of the screen, what's new? So I think they have missed a little bit the point to find the right answers to how to use stereoscopic 3D on a long-term basis, and that is still something that is not clear whether stereo will stay. It looks like still there are stereo productions made, but it's not as 4 years ago. Completely different. That's on my axis of modalities. A different way is done going towards higher resolution. So this is actually a test setup at BBC, and it was together with NHK. NHK is, if you don't know, is the Japanese public broadcaster. They also have a big research department. They developed a system that is capable of capturing, transmitting, and displaying 8K resolution. At that time, 60 frames per second. And BBC did a test with NHK during the Olympics 2012. I was quite amazed, and I think this is an example. This is a previous test production. It's just 1 frame. So this is the equivalent of a 32 megapixel image. And imagine this in full video frame. I was amazed by the test production at the Olympics when you had, for example, a shot of the gallery, and you could see a lot of prominent faces there, and they just kept it there standing. So they just had a static shot of the gallery, and you could see, there's the Queen, and on the right, there's Tony Blair, and the recent Prime Minister Cameron, and others, and you could, your eye were tracking the gallery, and that's what makes a change. So with SD resolution, if you would have to cover something like this, you would have to zoom in, and then you would pan the camera to show person A, person B, and so on. Here you can just leave the viewer's eye to track these persons. So that also requires already thinking through, hey, how do we do our camera work? And it requires something in media production is called the grammar, how you produce a film or video. So these are definitely changes, and they are changing towards more immersive experiences as well. Yeah, I mentioned already the Oculus. There are more other head-mounted displays coming up, even down to the Google Cardboard, which actually was, when I tried it, was better than the Oculus Rift 1, because I think they just used better optics somehow, even though it's still less than a euro or something probably per lens. I think we will see a lot coming in the next years. The question is, will it stay? It will only stay if we are able to produce content or user experiences for these devices that are keeping the broader public, the broader audience hooked to these devices. At the moment, we see a lot of interesting projects and demo productions. One directions the Oculus was supposed to be is just gaming. But now people find out, hey, you can just play a game with the Oculus because everything changed somehow. I can't see the keyboard, for example. I need different ways to navigate in this game. And of course, it's also back to stereo. Usually, you have the ability to render stereo. I had this experience some years back when I saw a pilot from a game studio, and that was just when stereo was taken up in the cinema. So the games guys thought, well, we can of course do stereo. We have 3D. We just render out a second channel, and off you go. It's stereo. But I saw this pilot and thought, wow, this looks really crap, because suddenly you could see all the tricks they are doing in gaming, like they use billboards for trees, and of course you can now in stereo see trees are flat, so something is wrong. That's again a good example where introducing new technology to a medium changes completely, or has to change completely, the way you produce the content. Because otherwise, you're not making use of it. It's the opposite. It might even, in some cases, look worse, like the billboard example I gave. So there's always this cross interdependency. You always have to introduce content or experience with a new device. Otherwise, it would not be of interest and phased out soon. Temporal resolution again. This is also something in the context of displays and in particular with head-mounted displays. So this is actually a test. You can call the website which is mentioned here, and it's for testing your display setup. It's meant to be a setup for a test for PC displays. And one problem you have, mentioned earlier, is the standard LCD display has 60 frames update, but the difference to CRT monitors is the image is staying longer, so it's staying the entire frame duration basically. Whereas with CRTs you had more a delta impulse and much shorter sampling of the temporal information. So what happens now, if you are tracking a moving object on your monitor, you see what happens on the right. You see, because the object is moving, your eyes are tracking it perfectly. But because it's moving over the sampling grid of the monitor, your eyes perceive the image blurred. Yeah, the only way to improve the blurriness is by increasing the frame rate. Or what is done here in this light boost example, they are shortening again the duration when they show the image on the LCD display. So in other words, they use something like a shutter, and that again reduces the blurriness. So I mentioned this in the context of the Oculus. In head-mounted displays, it's even worse because your head can move as well. Imagine you have a perfectly static scene. Your eyes are tracking an object, but your head is moving, and suddenly your display is introducing blurriness. because the sampling rate of the display is not high enough. So there were some considerations that you need actually something like 1,000 frames per second in this order to get a very high quality image. But of course, there are other tricks like this light boost you can use to get better quality of the display. Yet another way to interact with 3D is just using tablets. So this was an example Intel actually produced or sponsored the production, and it's basically a story, an interactive story put together by the University of Southern California. So they are having a story with flying whales, and you can go inside a flying ship and follow these whales. And this is just a mocked-up story. So they said this in Victorian times. But the innovation is here. It was demonstrated on the Intel booth. You can use tracked tablets to really participate in the 3D room. So you don't need a head-mounted display to work in a 3D room. You can use your tablet. That's an augmented reality application, if you like, and you can interact with the room. That's not the only demo for augmented reality, of course. But what it shows is it's a long way to get to some interesting content. So this was a kind of one-off production. I think you see University of Southern California, they have a long-term element or interest in it to develop this story over time. But at the moment, I would think it's a good demonstrator. You take your mobile, your smartphone, or your tablet, and you interact with the whale. But is it good for anything longer than this? Wow, I can now go around the whale, and I can, if I touch the whale, it's reacting. It's a great demo, but would it attract people longer than just the 5-minute slot or whatever you have in an exhibition? That's the answer. We are not sure how to give this. So in the last section, I am going over a few creative tools. So what we're aiming for is high fidelity graphics, but we also want to add some interactivity, something that is beyond a photograph. So 3D objects is certainly something we would like to have, but you also have to glue things together, semantic hooks, and of course we want animation. So let's go through a couple of examples. This is an ICG project, actually. This is just one example. There are other examples out in literature, and it's how to get from images to a 3D model. So there was, in recent years, there was a lot of progress made in structure for motion. So that's just using a camera to capture images from a place, and you put it through your clever algorithm. It's working out where the images were taken, and it's able to produce geometry. That's what's called structure for motion. What this work here from Michael Goetzle in Darmstadt is also showing is how to get high quality texture. That's something that was a bit neglected in recent years, and it looks quite amazing. This was actually demonstrated at SIGGRAPH, if you have shown it. It would be better to show a video here, but I'm running out of time, so I'm going to the next example, which is interest in industry. And this is an example from Intel. It's called the RealSense technologies, which is integrating depth sensors in devices. And here that becomes also the potential that people are using it, and they will scan their favorite models or everyday objects in their, or even their living rooms. And I think we will see a lot more content coming from the user end. That might not be perfect content, but it opens up a lot more scenarios to do something with this content. However, it's a long way from some scanned objects to something that works. This is an example of the Unity editing suite, which is actually, you can import objects made in your favorite modeler, or it could be your scanner. But you have to put some semantics on it. You have to put some functions on it, like if you want to touch a door, it should open. These things have to be specified, and this is at the moment still a very labor-intensive step. So it would be also possible to do more using clever computer vision algorithms to assign semantics to objects. I don't think I have another slide here. Yeah, I skipped because there's another project we have here at the IBCI looking into scene analysis, basically. Of course, visual media would not be complete with the moving pictures. And from computer graphics, that is, of course, computer animation. That's really a requirement to make interesting media in games, for example. There's no game without animation. So the question is how to get to these animations. This is a well understood pipeline in game production, but it is very labor intensive. So computer animation guys are really amongst the most high-paid labor force in post-production and game production, because it requires a lot of skills at the moment. And it's also not really live. There are examples of using motion capture to do live performances, but this is still very experimental. So again, with computer vision, there are now a number of upcoming new ways to support this setup. One is free viewpoint video. And I have an old example here. I worked a couple of years ago. We did a capture of sport events. So this is a virtual view, free viewpoint video. So apparently this was done for telling a story. So sport commentators had an interest in changing the viewpoint, because however many cameras you have on a set or on a game, you have never enough to show the incident from the right angle. So having something to move around the viewpoint is a big plus, a bit interest in sport commentary. Again, this is used as a professional tool. There are clear use cases. Free viewpoint video can also be used. I think there is one example here. We also captured sports scenes and streamed it to a prototype WebGL interface. And the viewer has now the possibility to navigate. Basically, navigate is relative. He can change his angle. Although this sounds like a very interesting move, to me it's still a bit questionable whether people are prepared to do that, because what would be the option? If you have, let's say, a high-quality football game, would you change the viewpoint? Yeah, maybe you would try it once as a kind of gadget gimmick, but then there's a good reason why there's a high-paid crew in the sports van, because they know how to switch from camera to camera so that you are not lost in the game. Because having the ability to move around also gives you, of course, the option to get lost in something where you don't understand what's going on. So that's again, free viewpoint video is interesting new medium, but what is it actually we want to tell the user or the viewer? So to wrap this up, or to come to the actual interactive content, I mentioned all these new pieces of technology, animation merging with real world. But how do you make a story out of this? So that's often called digital storytelling. You could just use a games engine, but still you need to think through what is a narrative you want to put down. And that is actually one of the bottlenecks with this digital storytelling. Yes, we have plenty of digital assets now. I mentioned users using their tablet with depth sensors to scan in objects in 3D. But what are we doing with the content? I don't have an answer to that. So from the media industry, there are only experimental productions so far. So it's well understood how to produce television, film, games, but digital storytelling is still at its infancy. So possible directions I see is using social media and crowdsourcing. That could be actually quite good direction. Just let it go in the internet and see what users are coming up with. That might be the way forward. I also see computer vision is very important to support users. So I mentioned this 3D scanners or motion capture. What we definitely need is we need better tools for experts, but moreover for non-experts, because I mentioned the animation example, modeling. You can't really use a high-end modeling package like 3D Max or Maya. You have a steep learning curve, and it takes even experts years to get mature. So we need better tools to put together stories for non-experts. With modeling, I mentioned laser scanning. There's a lot of things you can do automatically already. Semantic annotations, yes, something starts to emerge. But animation, for example, this is absolutely almost zero. You can capture things automatically, but how you put it together, we are lacking the tools. This is just one example which is related. It's a recent project where we are also aiming to use new kits like tablets to come up with more simpler to use intuitive interfaces to edit on set. So that was set up in visual media production here. Idea is to have a set editor where you can use a tablet to move around virtual objects that are filmed together with the real actor. These kind of tools, I think I would also like to see in the hands of non-professionals. And I think with these tools we can build better worlds in 3D and better experiences. And this gives me my last slide. Just recap here. So I think immersive and interactive programs are really exciting. They develop from graphics and games technology, and there's a lot of going on, in particular in gaming. And we are at the moment seeing the re-emerging of VR and AR technology. But, and that's coming from my media background, I see a lot of lack in the content production tools. And this is where I see the scientific community can still help a lot. And yeah, possible future, there is not one future. I think we are seeing here quite interesting melting pot of new tools, new display technology, new software technology. Where it is going, this is very, very undefined at the moment, and it can go in many directions. So that's it from my side. And I think you were planning to have a question section.
Thank you very much. Can you hear us? Oliver?
Yeah, I'm here.
Can you hear us?
Yeah, I can hear you.
Okay. Any questions? Thank you very much for this very interesting talk. Any questions? Usually I have to start with the questions as a warm-up. What I found in your talk was actually two things. You mentioned that, for example, on the one hand side, you are not sure about the future of stereo in cinema and also in TV because of the lack of, stereo productions, right? And it could probably be that stereo is not very successful because it's not accepted at the moment. In cinema, it's probably more accepted than stereo TV. Stereo TVs are not bought. And that might be the reason why companies stop doing stereo productions or drive stereo productions down. And on the other side, you mentioned that obviously television resolution increases up to 8K times 4K, and the question is, why do you need that higher resolution? Because at some point, at least for television setups, you reach a perception limit where you can just not resolve the resolution at normal viewing conditions anymore. So, do you think that to solve both problems, to do something meaningful with the high resolution televisions that you get, and the problems that you have in terms of acceptability of stereo TV, do you think you could do something better with the high resolution in televisions? For example, doing light fields where the spatial resolution on the television could be used for multiplexing angular resolution to solve all the problems that you have with classical stereo TV that you have at the moment. So what do you think about light fields in terms of media production in future?
Yeah, that's that's again a complex question, and there's probably also only a complex answer. Let's start with stereo. Stereo, I think I mentioned why I think the interest in cinema has dropped. That's because people didn't get it right to come up with a narrative. So what is a problem? Why are people why should people watch 3D? It's always something you have to keep in mind. There must be a reason for it. You can perfectly imagine you have a movie. So you put in a movie, just trying to find an example. I can't come up with an example. Your favorite movie. So you can perfectly watch it on television. You could even probably watch it in black and white. Why would you need stereo? Does it add anything to the narrative? You still understand it in black and white. So people miss the point to come up with the answer why to use stereo. And there are only very few examples of people that really thought this through. It was mainly the wow effect people were trying to bring in, so that people started, yeah, we have to go into the cinema to see this dinosaur tail coming out of the screen. I think that's something that is still an open question. If somebody can answer this question, I think that we will see continuous streams of 3D movies. And it's the same thing for the television. It's only very few examples are really where you think, yeah, here stereo works. There's also, and I'm also now coming to your question, why not using things like integral images, light field displays, and so on. It's quite limited what you can do with these devices. Also with stereo, currently in your living room setup, the screen is relatively small. So what people are doing is they are scaling down the stereo basis. That means you still want to see the entire game of a football match, for example. That means the players are now as big as a guinea pig or smaller. So that's not realistic. Yeah. So why are you using 3D? There must be a reason. Of course, stereo can disambiguate some things, so you can use it. You can as a better scale of the spatial spatialness of scenes. And that's also something. But was there a follow-up question or?
My point was only that I think that stereo is the wrong way of doing 3D, because you have, in particular for stereo TV, a lot of problems. Of course, in the narratives, if you think about depth of field effects, that's not possible to do in stereo. So you have a lot of limitations when you produce stereo content. And if you think about stereo televisions, you know, people don't want to wear shutter glasses or polarization glasses, and if you watch television on your couch, with your head like this, it won't work. There's a lot of things that limit the television experience with stereo TV, and that's why people just don't buy it. But if you have a better 3D technology, which is not stereo, which could be something like holographic or live field technology, which you could probably implement by, you know, making better use of the high resolution displays that you get in future, then maybe all of these problems are gone, because you don't have problems with accommodation disparity issues anymore that you have with stereo at the moment. You don't have problems with depth of field issues that you have with stereo content at the moment. You don't have problems with multi-viewer. You don't have problems with wrongly aligned eyes relative to the screen, and so on. So all of these problems are gone, and then the question is 3D better than 2D or not? Does 3D add something to the experience or not? But at the moment, people do 3D wrong. That's the problem. That's why don't people just go with it. In the cinema, it's not so much of a problem then for stereo TV, but people just don't buy stereo TVs, because once you have got that 3D experience, this wow effect, you just don't watch it anymore, because you don't use it anymore because you have so much limitations. But that might be gone with a different 3D technology.
Yeah, I can only agree. Of course, there are effects like visual fatigue on stereo, and because the screen is further away, it's more a problem if you're in a living room closer to the stereo set. Yeah, I can only agree. We all want the holodeck. That's what we want. The question is are light fields giving you already the holodeck? And I think the answer is no. What people don't see immediately with these kind of systems, so they are based on the integral image idea, which again is something introduced by Lippmann, I think more than 100 years ago. Which is an integral image, basically is a light field display. What these displays give you is you have one way of implementing it is building a lens, taking a lens array, a lens LED array, and putting some display behind it. So you're making from some pixels, you're making a super pixel, which is then through the lens LED a directional pixel. The problem with this technology is, so first, you are simplifying resolution to get light field, which gives you 3D stereo, with all the benefits of right accommodation and so on. But what you're not realizing immediately maybe is that these displays give you only a very limited range in depth. So you can only produce, depending on your resolution, something like 50 centimeters around the screen. And that again, this is not the holodeck. It's not like you look out of the window and you see some forest on the far distance. You can't present this on an integral image display. You can only present objects around the screen with a limited depth.
But the point you make is correct. It only depends on the resolution. So if you have a really high spatial resolution, you can get really large light field in the large field of view. It's only a question of high resolution, the display behind the lenses. So what the other part of my question was, if you look at these kind of ultra HD resolutions like 8K times 4K, I was wondering what you do with that resolution on a television set. You need either a really, really large television set and sit really close to it, or you just don't need that resolution because you don't resolve it. So in future, you might have a high spatial resolution for displays, and you might have blown up your television set up to a size that can be within your living room, and you won't sit 10 centimeters away from the television set to get like a really large immersive experience. So what do you do with that resolution? And one point would be to maybe think about to multiplex it in a different way, that you can deal with 3D. So of course this only will work if the resolution is available, but it seems that there is a trend towards a high resolution in the future. Question is, if you stick with 2D displays and high resolution, what do you do with all of these pixels?
Mm-hmm. Yeah, that's a fair proposition, and I'm sure people will try exactly that out in the near future. Still, it depends. It depends a bit about your setup. If you have ultra high definition and you present it at a screen which is I don't know, usual TV set, and you're 10 meters away, then you could replace this ultra high definition with an SD display probably, and you wouldn't notice the difference because you're right in your angular distance. But if you build up a big display wall in your living room, and also this is feasible, I mean, displays doesn't cost you a fortune anymore. That might be a different way of seeing it. So there are different ways of using the medium. I agree with you. I think we should try out using optical image lenslets in front of TV sets. That's a good idea.
And there's certain constraints in your living room. You probably would not sit 10 meters away from your screen. I don't have that large living room.
Okay, it was an extreme example, yeah. But even 5 meters is quite a bit away. I think you should sit quite close to your display in order to enjoy the resolution.
Okay, that was my question. What other question?
I have a question regarding the virtual reality goggles. Do you think that this trend is a bubble or it is a future?
Sorry, can you repeat this? Was a bit.
Do you think that the trend for the virtual reality goggles like Oculus Rift or the Sony Morpheus project, is this a bubble which will burst, or is it, has this technology a future?
Yeah, I have seen so many of these things going in cycles. So I think there is a danger that it will be a bubble. But I think there's also, on the other side, there's also a good chance, if they get quality right, that it will stay. But whether it will be a mass phenomenon or just a niche product, I'm not sure to predict at the moment. So I don't know. It can be a bubble, and people find, well, yes, interesting piece of technology, but the content is not of interest. Let's wait another 10 years until somebody comes up with new ways of producing nice content, and then we will see the cycle we have seen in stereo. But if they get the quality really right and attractive, there is a chance that it stays.
Okay, thank you.
More questions?
I have a question regarding the frame rate of cinematic movies. When watching the Hobbit installment, the first one, The Unexpected Journey, which was shot in 48 frames per second, not only did the shot frames look really clear and really unusually clear, but also the computer-generated scenes looked really fake. So, do you think there is some sort of some tug of war between the image quality that can be computer-generated and the frame rate that is used to display these generated images going on?
Sorry, again, the audio is breaking up a bit. I think your question is about high frame rate video or movies?
It's about the frame rate in movies, and when I watched the Hobbit installment, the first film, I encountered the problem that the computer-generated sequences in these movies looked really fake. So a problem which wasn't there when films were shot in 24 frames per second. So do you think there is some sort of tug of war going on between the image quality that can be computer-generated for computer-generated scenes and the frame rate at which the scenes can be displayed then?
Yeah, I can only guess. I would guess what people got wrong is because of lack of experience, they haven't created the CGI with the same characteristics that would be necessary for 48 frames per second. So in other words, people are used to produce content for 24. So they know they have to put in motion blur so that it looks realistic. And I think you can just, I think that's just no fundamental problem. It's just they haven't tuned towards the higher frame rates.
So you think the real content at 48 frames per second looked realistic, more realistic than 24 frames per second, or was it a general?
It looked the parts that were really filmed, they looked unusually realistic, but that wasn't my problem actually. I liked that, but my problem was that the computer-generated parts looked like playing a video game.
So it's maybe for realistic scenes you are used to very really high frame rates, and when you play your games at your computer you're used to slow. When you watch television in cinemas that are computer generated, you are used to 24 frames per second. Also,
yes, maybe, but I watched all the Lord of the Rings installments, and the computer-generated scenes were fantastic. Only when they help it with the 48 frames, the part, if for people who saw it, where they run through the caves, it looks really like a jump and run game.
Yeah, so I've seen similar things when they switched from SD to HD. That people suddenly in post-production started to quote for a production 4 times the budget, and the explanation was, yes, with HD you have now to work on a much finer detail, and you have to adjust the motion quality you are blending into of the animation into the real footage. You have to tune this much better, because otherwise you would see the problem. And I think it's the same problem here. So people have not yet adapted to the higher frame rate. So they have to find the right means to produce the content so that it looks realistic. So
it's, in your opinion, just an experience issue of the producers?
Yeah, it's the graphic pipelines are not adapted to this content. It's post-production houses. They work with an experience, or their capital is the experience of their guys. So the experience of the animator and the compositor, and the sum of this experience goes into a production of a piece of animation in a video. And it's like camera operators that they also have to adapt to this higher frame rates, because they have a certain way how they, for example, do a pan. Because on a cinema camera, they know they have to pan very slow and to do the shutter to full integration, so that they get some motion blur. If they don't get the motion blur, you will see some shutter effects. And that's the same thing with animations. It's highly complex. You have to understand all these things with when you have to produce the right amount of blur so that it looks realistic, like a camera image. And these are the effects the industry is not yet tuned to.
Okay, more questions? Going once, going twice. And thank you very much again, Oliver.